So here you see the typical Waylay environment that you're probably familiar with. So for those that have this Waylay environment, as of the June release, you will see appearing a new tile called TS Analytics. So TS Analytics stands for Time Series Analytics, is a specific optional priced module into our Waylay product that allows you to build algorithms for anomaly detection and prediction based on the data that is in the time series database. Okay, so I opened here the analytics module, and now we are going to look for a specific data set of what we call a resource. So I'm going to look for our engine. Okay, so it's the water pump that is basically running at a certain rotational rate. Okay, you see it here, right? The pump is just rotating just fine. This is what we call the normal behavior or the expected behavior of our water pump. Okay, so this time series analytics visualization tool allows you to visualize the data at any time granularity. Here you see it on a, let's say, a minute level. It has pulled the level, but you can also zoom at a much finer granularity rate. Here you basically are going to look it up at almost a minute level and see how it behaves in this time granularity time frame. Okay, so in this case we have actually recorded data where the pump is misbehaving. You basically see a drop in rotational rate, for example, due to a blockage. Somebody left, I don't know, their sweater on the pump, and it got in between the engine, and now it's rotating at a low rate. Obviously, if this situation continues to run, not enough oxygen is going to be pumped into the fish tank, and basically fish are going to die. Okay, so what we now can do is basically consider this as the normal behaving condition of this engine, and we're going to allow the system to automatically create a model for this normal configuration. So now I let the system automatically detect what is the optimal model to describe this the behavior of this engine. Okay, so in this case it has detected automatically a few things. Okay, it has detected there's a seasonal pattern every 12 minutes. But we're not really interested in the seasonality at this moment. We're more interested in a fixed model that is basically going to say, hey, my engine should operate within this or that boundary. Okay, so we're going to let the system now calculate what is the optimal model for this engine. So now it has selected a fixed model, and it has automatically filled in a number of parameters that accurately describe the normal behavior of the engine. If you're interested, you can actually expand this configuration and see or edit the settings that the machine has automatically detected. So here we basically, the machine has basically selected a fixed model with a acceptable deviation of 111.237, and it can go up or down. So for the experts, they can now edit this as they see fit, or they can basically choose another model out of the library of models that we have available to describe this single variate data set. Okay, so you can override it, or you can let the machine to basically select what is the best model. Right? Obviously, in most cases, you want to let the system automatically determine what is the best model. Now, once we have selected our model, we can now apply this model to a different set of data. Okay, and typically we call that the training phase, where you're going to evaluate whether, based on some pre-recorded data, the model is behaving as expected. Okay, so here now we have created our model. I'm going to press the calculate button, and it's going to evaluate the model in this time window. And here clearly in this simple example, you can see that the data set after 11:30 here is significantly different from the normal behaving operation of the engine. And all data points here are basically tagged as anomalous. Okay. For those that basically want to see how it works internally, well, here you can basically see the residual values for each of these data points and how they differ from the model. You can basically also have a lot of details here with the anomaly score and so forth. Okay. Now that let's say we're happy with this model, we can obviously save this model as a new configuration. So let's do that. Let's press the save button, and we're going to call this rotation engine model 1. Okay. So let's save that now. So this is now saved, and the next step is now obviously to define the rule that is coupled with this new configuration and this new model. Well, here we click and this icon here, and it's going to take you to the rule editor itself, right? So now you are a business analyst that is basically using the anomaly sensor that your data scientist has created. You see here basically the configuration that was used, and you can now build your rules against that anomaly sensor. So let's say we want to couple an action to this anomaly sensor, which could be SMS, for example, which is basically this, where we can say, well, if the anomaly sensor detected an anomaly, we are basically going to send an SMS to a specific user. It could be any telephone number that you have available. Okay. Now, there are a few things that you still need to configure on your anomaly sensor. First of all, in most cases, you're going to execute this anomaly sensor either in real time, whenever a new data point comes in, or you can basically say, hey, I'm going to execute it every 15 minutes, for example, which is 900 seconds, based on a window of say the last 15 minutes. Okay. So basically, what's going to happen now is that once you initialize this template, they save this template, and you initialize this template for your all your engines in the field, you are basically going to run this in a periodic way that is going to test for the last 15 minutes, check whether any anomalies are detected according to the anomaly algorithm that we just created in the TSA designer. And if an anomaly has been detected, well, then I'm going to send an SMS to the field engineer. So let's say you're going to test this, so you can easily test this using the Waylay Labs environment. As you know, we have an A/B testing capability into our platform too, where you basically, for example, are capable of running and testing your template with the anomaly sensor against one or multiple resources using a specific data set, and then and you can basically test to see in real time whether you're happy or not with the results. Let's say you are not happy with the results. Well, then you go back to the TSA Analytics Designer and you update again the configuration. Okay, so here, if I go back to my turbine, here I've created a few configurations in the past, and I can basically version this and update this as I see fit. Okay, maybe you want to change the algorithm, move it from fixed to an ARIMA, something that is autoregressive, that automatically adapts. And whenever I change the algorithm, I can always go back to my rule, and my rule will automatically pick up this specific configuration, but the rest of the business logic does not need to change. Okay, so this is a very powerful concept that allows you to basically tune and tweak your anomaly detection algorithm and bring it into production very fast.